Hello, let's assume you are in an examination and you are asked to find the value of negative 1 to the power of the square root of pi. How will you go about solving this? This is an Olympiad maths exam question and you are asked to use the Euler identity. How do you solve this? As we solve this question together, don't forget to give this video a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified maths content. Now, if you look at that expression very well, that will take your mind back to Euler identity because you are asked to simplify or solve using the Euler identity. Now, from the Euler identity, you can recall that the exponent of the value of I pi plus 1 in Euler is equal to 0, right? So that tells us that the exponent of I pi can be equal to negative 1. This brings us to this expression. That means negative 1 can simply be replaced with the exponent of I pi. So that means this expression can be simply equal to this whole expression. So that means the exponent of I pi multiply the square root of pi can be equal to negative 1 multiplying the square root of pi, right? So this cannot be disputed. So how do we solve this? Now let's take our mind back to the laws of indices. From the law of indices, this expression can be simplified if I have a to the power of x multiplying the power of y. This can be simply be a to the power of y multiplying the power of x, and this can be equal to a to the power of x multiplying by y. Whatever you do, and that is exactly what you're going to have. That means I can multiply the exponent. So that means this will give me the exponent of I pi multiply the square root of pi. And this will be equal to negative 1 multiplying the square root of pi. Great. Now from this expression, I can have this to be the exponent of I pi multiplying the square root of, or multiplying this expression will now give me pi to the power of 1 divided by 2, right? Recall that if I have the square root of x, according to the law of indices, this can be x to the power of 1 divided by 2, right? And this whole expression will still give me the value of negative 1 to the square root of pi. Remember, this is carrying a power of 1, right? And from the laws of indices, I can simplify that. But before I do that, I can simply throw this out to give me the pi of 1 multiply the pi of 1 divided by 2. All of these will be to the power of I, right? Indices permits me to do that, and this will be negative 1 to the power of negative pi. Great. So what do I do? From the law of indices, you can find out that if I have a to the power of x multiplying a to the power of y, this will give me a to the power of x plus y, because that is exactly what this expression will give me. Exponent pi 1 to the power of 1 multiplying the exponent power of pi half, right? That is what this expression will give me, and that will give me the exponent power value of pi 1 plus what? Half. And this 1 plus half can simply be equal to 3 divided by 2. So that expression will automatically give me the exponent value of pi to the power of 3 divided by 2, right? All to the power of I, and this is still equal to my negative 1 to the power of the square root of pi, right? Good. Now that is that expression. Now, having gotten to this point, we can still simplify. Remember the law of indices. I can now bring this in, and this will give me the exponent value of I pi to the power of 3 divided by 2. And this is still equal to -1 multiplying the square root of pi. So however I put this expression, this is exactly what this can give me. So this can still be equal to the exponent value of pi to the power of 3 divided by 2 multiplied by I, and this is the value of -1 square root of to the square root of pi. So look at this value very well. We're still going to remember the Euler's identity. From the Euler identity, you'll find out that if I have the exponent of theta I, right, this can be equal to the cos of pi plus I multiplied by the sine of pi, right? So from this expression now, if I expand this will give me this expression to become the Euler value of pi to the power of 3 divided by 2i will now be equal to, which is equal to -1 to the square root of pi, will now be equal to the cos of pi to the power of 3 divided by 2 plus the I value of sine to the power of sine multiplied sine of pi 3 divided by 2, and that is the value of this. So that means the value of -1 to the power of the square root of pi can still simply give me the cos of pi to the power of 3 divided by 2 plus I multiplying the sine of pi to the power of 3 divided by 2. And that becomes the solution to that expression given to us up there. So you see, very, very easy. With this, we can find the value of -1 to the power of pi using the Euler identity. I know you did enjoy watching this math expression or solution. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified maths content. Thanks so much for watching, and bye bye for now.